Hello and welcome. If you recall from the last video, I got a little agitated because when I was trying to store direct ASCII bytes into the screen buffer, I was getting a little bit surprised by the VDG and what it was doing. And so I had to take time out and just explain what was happening before I could actually show the video I really wanted to show. And I said, okay, now that that's done, I will be able to show the video I wanted to show next time. Well, it's next time, and I got agitated again. I fell for it again, so I wanted to show you what was going on. So I'm like trying to make this app where I'm going to have some labels on the screen, and I'm going to have some text on the screen, and I did what I thought would make sense. Well, let's. So here's what the code is printing so far. We've got these labels numbered from 1 to 16, and we're using the green on black style, because if you saw in the previous video, you saw that's kind of what you get when you use the ASCII codes for these numerals and for colons. So I'm just going with it. So I'm just going to say, okay, let's do green on black. And so here's what I want to do. I want to add another label right here, and it's just going to say RND returned, and it's going to show you the random number that was returned. So I want to add code that says RND returned right here. So let's take a look at the code that does it, and let's see if you can find the bug. So first, I'm going to add these 3 lines of code. They load X with the location of the string that I'm going to print, RND returned. I'm going to load Y with the location in the screen buffer that I'm going to print it at. So adding 14 just brings me 14 characters to the right from the very beginning of the screen buffer. So it'll be the top line. And then I'm going to call a subroutine that prints it. So using the X and Y registers that I set up, print string will print the string I pointed to at a location I pointed it to. So let's take a look at print string. We use the A register to go character by character. So we've got a loop here that reads wherever X is pointing. If it's null, I'm going to assume that my string is a null terminated string. So if A ends up being 0, then we're done, and we branch to print string end. Otherwise, we take whatever character we read and we store it wherever Y is pointing, and then we move Y along 1 character, and then we branch up to the top. We repeat. When we get down here, we return. So far so good, right? No bug, and we're pretty much done. The only thing left to look at is the string itself. So FCN says make me a null terminated string. So it will add a 00 here at the end, and then that's the string it'll print. So what's the bug? What did I do wrong? What did I do wrong? What's going to happen when I run it? All right, let's take a look. We got black on green. Come on, silly. Come on, of course, I'm giving it uppercase letters. It's going to give me the black on green style. No one wants to see this. Come on, come on. By the way, notice the space is still a black space. So like it's kind of defaulting to this green on black everywhere. But if I'm going to give it capital letters, it's going to give me these capital letters. So come on. That was just silly. That was me just being kind of brainless. So the fix is obvious. All right, let's try this. The bug is fixed. Now we're going to get what we expect. Here we go. What? What is this? Hold on. This. What? It's like the right number of characters, right? It's got the space in the right place. And the colon's okay. Why do you do this to me, VDG? Why do you hate me? Really, the question is, why do I keep falling for the same thing over and over again? What's my problem? All right, let's take a look at Unravelled, folks. So if you recall from last time, I got really hung up on this. Basically, all the characters whose code was before hex 40 would cause this to be set the carry bit, and then we would skip over to 340 and we would EOR with hex 40. We would invert bit 6. So it's like, okay, if I'm going to do like those kinds of characters, I'm going to have to do... But that's not the only tweak this thing does. This thing does a lot of stuff. I mean, come on, man. You read like one line of code and then you think you know what PUTCHR is doing? No, man. Come on. Keep on reading. Check this out. It checks to see if we're upper or lowercase, and you know, if we're uppercase, then we'll like skip that. But then we do this. So there are cases where we not only EOR with hex 40, but we'll AND with DF. We'll clear bit 5. We force lowercase to be uppercase. Honestly, I don't quite understand these comments. You know, here we're forcing lowercase to be uppercase, and then what? In the very next line, we're changing uppercase to lower and vice versa, and we're doing it through a different bit, inverting bit 6 for this, but clearing bit 5. I don't think this is a fully descriptive line to tell us what's going on. But what I do know is this is yet another thing that PUTCHR does for us that I'm not doing. I'm just like poking some ASCII codes and expecting the VDG is going to show me something reasonable. And really what I need to do is to simulate what's going on with PUTCHR. So if I've got a lowercase letter, this is going to end up happening. So I should do both this AND A and this E or A and make sure that that's what I send to the screen. But only if I'm supposed to. So let's take a look at that code to do that. Here's the updated code. I'm just going to show you the stuff that hasn't changed first. So as we are drawing the screen, the same 3 lines of code to call the print string routine. This is the string we're going to print, this is where we're going to do it, and this is how we do it. And let's just double check print string. Also unchanged. All this does is it cycles through wherever X is pointing, and then it stores it to wherever Y is pointing, and it's done. And then let's take a look at our actual string. Same thing. Lowercase letters, that same space, that same colon, no different. So there's something that I'm doing differently in the beginning. Let's take a look at that. So at the very top, the very first thing I do now is I call a new routine called tweak lowercase letters. So I point X at that string, and then this is going to modify the bytes in place so that any point later when I go to print that string, it will be printing these tweaked letters. What does this do? We go character by character wherever X is pointing. We stop when we hit the null terminator. So if we hit the null terminator, we're done, we're out of there. Otherwise, we ask if we're in range of the lowercase letters. I'm not doing the exact same tests that PUTCHR is doing because I don't want to do all the things that PUTCHR is doing because I still want to get my nifty green on black. I still want, you know, the numbers and those symbols to still be green on black. So I'm being very precise here, very surgical. I'm only addressing when a character is a lowercase letter. So compare our character with lowercase a. If it's lower, we don't care about it. And so that means we're just going to loop back up to the top and go to the next thing. Then compare it with lowercase z. If it's bigger than lowercase z, we don't care about it. So we just go back up to the top and continue looping. If we made it down here, we now know we're at a lowercase letter. We're between little a and little z inclusively. And then we do those two things. We AND with df, we EOR with 40, and that will duplicate what PUTCHR does in this particular case. Then we write that back into wherever X is pointing. So remember, we're not printing anything here. We're just tweaking the characters for a later print. So wherever X was pointing, we store that back in. Notice we do a -1 because we already incremented X when we read the character. So X is now pointing to the next character. So we're going to go ahead and just store this 1 before, which is where the character originally was. And then we branch back up to the top. So this is totally going to fix it, right? Totally going to fix it. Care to make a prediction? You think it's really going to fix it? I'm calling this one now SS2. Booyah! Just what I wanted. Green on black. The space is still cool. The colon is still cool. All that stuff's still cool. All right, we are back on track. But that doesn't mean that we're done. Because fool me once, shame on you. Fool me twice, still shame on you, PUTCHR. But fool me 3 times, and maybe now a little bit of the blame goes to me. So I wrote a little code to try to demonstrate exactly what to expect when you start directly storing characters into the memory locations rather than using PUTCHR. So I'm just going to walk you through this code. It's very simple, but it's going to at least illuminate what to expect. So at the beginning, I'm going to clear my screen. I'm going to do this print all bytes. Let's take a look at print all bytes. It simply loops through all the possible byte values, 0 through 255, and it puts them on the top half of the screen. So B is going to be the byte, X is where I'm going to stick the byte. I stick the byte wherever X is, I increment the byte, and so long as we haven't wrapped around, then we go back and loop and continue doing that. But once B is wrapped around to 0, we're done. So that's the first thing that we do, this print all bytes. We just get to see everything. What's the next thing we do? We load up the string that I'm going to show you in a moment. We run the routine I just showed you to tweak only the lowercase letters, nothing else. And then we put that in the lower half of the screen. So X is now going to be the tweaked version, Y is where we're going to stick it, and then we run that print string routine again, just like we had seen before. What is this stir? Let's take a look at the stir. Here we are. It's just a bunch of characters. I just went on my keyboard and I started typing all the keys in order. So here's like the shift numerals up here, and we got, you know, like it kept on going. I would do shift and not shift, shift and not shift, and then of course all the lowercase letters. This isn't all the characters, but this is the characters that I might possibly want to display on the screen, since I'm trying to do some green on black goodness. So I'm curious, like, will all of these symbols show up in the range where PUTCHR would do its thing and then I'm not doing its thing, and so I'm going to still get green on black? Or will some of these be black on green? Will it be all the same? Will it all be different? I don't know. Let's run it. Alright, so this top half from here all the way on down, this is showing us what the bytes look like, the raw bytes, without PUTCHR getting involved. It's interesting to notice that all of the green on black and all of the black on green, they exactly mirror each other. And since you've got 32 characters going across, that's exactly hex 20. So if you like add hex 20, you kind of flip from green on black to black on green. It's kind of interesting. And then we get all these semi-graphic characters that I'm not really concerned about for now. But this is the main thing. So you basically have every possible character in both inverted and regular. So what about that string that I hard-coded? By the way, I don't think I pointed out that double quote. The string actually starts right here, and I couldn't put a double quote inside this double quote, so this is probably an easier way to do this, but this is what I did. So my stir starts here, I got my double quote here, not null terminated, so then it directly bleeds into the rest of these strings. But anyway, so let's take a look. So my double quote, my numerals, everything is cool until I get to my exclamation point. That's cool. Then the @ sign, so like the ASCII for the @ sign actually ends up taking us into this area over here. But the ASCII for these symbols still keep us here in this area. And then after my percent, and I get to that little caret, a little hat, that's an arrow, and it's the black on green, and so on. I mean, you can do this comparison yourself as much as you like. It's kind of interesting that this tells me if I want to use any of these characters, I'm going to have to be careful, and I might have to do a little of the PUTCHR goodness. But if I want to keep these characters, I probably don't want to do the PUTCHR goodness. So in that case, it wouldn't be goodness. Anyway, this is how I kind of figured out what to expect. Now I'm definitely ready for the next video.